Hello, and thank you for joining me here at the School of Engineering. Effectively, what we do is post weekly tutorial solutions to common engineering-related mathematics questions. And it is our hope that we will provide solutions for engineers and aspiring engineers at all levels. And so the first of our videos will be looking at material elasticity with specific attention to Hooke's law, computing direct strain from direct stresses, a Young's modulus, and Poisson's ratio. And this will be for a 3D problem. And so without further ado, we will get right into the question. And so the question is that the analysis of an aerospace component yields the following direct stresses. So there's a set of three direct stresses in three different directions, X, Y, and Z. Calculate the direct strains in each direction. As I've said here, you can see that the question gives you values for the direct stresses in directions Y, X, Z, and also a Young's modulus and a Poisson's ratio. And what the problem wants us to do from the detail that they've given us, or from the inputs that they've given us, is to calculate the normal strains in all three directions. And so looking at the knowns and the unknowns, it looks very clearly like it's going to be a Hooke's law problem. And so for those of you that are unaware of what Hooke's law is or what it does, it's an important law to know, and specifically when studying mechanics of materials. And it effectively just states that the strain in a solid is proportional to the applied stress within the elastic limit of that solid. And so looking at the highlighted words here, you should now begin to see how Hooke's law is related to our problem. So it's effectively relating strain in a solid to the applied stress and saying that it's proportional. And so the variable that takes this Hooke's law concept from proportional to equal to is the Young's modulus. And so if we look at the mathematical representation of Hooke's law here, it begins to make a lot more sense. So we look at the sigma, which is in pascals, which is the direct stress, is equal to the direct strain, epsilon, multiplied by this Young's modulus, which is a property of each material. However, our problem is a 3D material or component rather, and so we need to use the generalized Hooke's law to calculate the strains in a given direction. And so clearly looking at the equations that I've displayed on this slide here, if we were to equate sigma y and z to 0, then the equation would look a lot like the equation that we introduced in the previous slide. So the generalized Hooke's law would look a lot more like the Hooke's law that we introduced in the previous slide. But back to the tutorial question, again, these are our knowns. We know sigma x, y, and z, and the question also gives us a Young's modulus value and a Poisson's ratio. And so when we plug these knowns into our generalized Hooke's law equation, we end up with our solution for the direct strains in the three required directions. So epsilon x, y, and z. In our case, they'll have values of 157, minus 314, and 287 microstrain respectively. And it's important to note here that microstrain, or strain rather, has no units. So thank you for listening. Please like, comment, and subscribe.